First example, kind of direct, is the following. So you're simply given that for a certain airline, so I'm here not in a very good angle. Certain airline C of x is 0.0005 x cubed minus 0.38 x squared plus 120 x. And this is the cost per x passengers. Okay, so knowing this information that the associated costs that an airline, a given airline, it doesn't matter which one, incurs when having to accommodate x passengers is given by this polynomial, this cubic polynomial. And so the question is now very straightforward to estimate. So estimate the marginal cost of an additional passenger if the flight already has 150 passengers. So when you're given, when you ask a question like this, I mean, there's not much to think about. I mean, you're given a formula, and for the cost, and you're asked about the marginal cost at a production level. So it's just going straight to the approximation that you know, which is given by the slope of the tangent line. This is the discussion that we had in the previous video. So we go straight ahead. So we know that the marginal cost can be approximated by the derivative. So we first take the derivative when for any value of x, and we end up with this quantity here. If you don't believe me, this is what happens. So we need to multiply. Remember, when we take derivatives of the sum of three functions, or two, or no matter how many, this can be written as the derivative of the first one, in this case minus the derivative of the second one, and plus the derivative of the third one. And here we use the power rule, so this should get the derivative of this gives us 3x squared, and when we multiply 3 by 5 we get this 15 over here. So instead of being so this changes from being 0.0005 to being 0.0015. That's x squared. Then we multiply 0.38 times 2, because the derivative of x squared is 2 times x, and that's what gives us the 0.76 x. And finally the derivative of 120 x is simply 120 again. All straightforward applications of the power rule. So now, but they're asking us, this gives us the marginal cost at production level, marginal cost at production level X. So for any X, this is the approximation for the marginal cost. So this is approximation. This is just an approximation. So the approximation of the marginal cost at production level X. But we're asked to estimate this when X takes in the specific value of 150. So you know they have 150 passengers. So you want to know how much it would cost you to accommodate one more. So using this formula, C prime of 150, which simply amounts to plugging 150 inside the formula. So just evaluating here. So where it says X, we need to put 150 because this is where we're being fed here, and then 0.76 times now X, we need to write 150, and then plus 120. And if you do the arithmetic, you should get 39.75. And so this is the estimation. So estimation of the marginal cost at production level level 150, which is the number of passengers. Okay, so that's one kind of question. So very direct. I mean, this is a kind of question you may find in a quiz or for the second midterm. Something very straightforward. Just what's the marginal cost? So give an estimate for the marginal cost at a given production level.